Aloha and welcome. In this video, we're going to be talking about firewalls. So what is a firewall? We've spoken a little bit about that in the past. A firewall, it's a network device, or it could be a software program that controls your inbound and your outbound traffic based on a set of rules. A firewall rule can be general or it can be specific. It can be general, like saying, we're going to restrict all HTTP traffic on port 80. Or it could be very specific. It could say, I'm going to block it from IP address 192.168.1.3 on port 22. You can be very specific with it, or you can be very general. So firewall, it's going to be used to separate two different security zones. One thing that we normally do with a firewall is we'll put that between our trusted network on the inside, our internal network, and the untrusted network, the intranet or the internet. So we like to separate ourselves from the internet using this firewall so that we can have security on the inside. So a firewall can be implemented two different ways. It can be in hardware or it can be in software. So we're talking about hardware firewalls. They're often known as appliance firewalls. These are firewalls that they're implemented in a physical device. So hardware firewall has a dedicated processor, it's got dedicated memory and an operating system. So the hardware firewall, it has faster response times than pure software one would have, and it also has the ability to handle high traffic loads. On the other hand, you've got the software firewall, and that's a firewall that's implemented in software and runs on a general purpose computer. A lot of you have a firewall in your system in Windows, and you can set your different firewall rules on that as well. So a software firewall typically costs less, but it's slower than a hardware firewall. So both of these hardware and software firewalls, they've got to handle unexpected situations like when your system crashes or something. So what happens when your system crashes and it's no longer functioning? It has to be configured to do one of two things. One is called fail open and the other is fail closed. When you have a fail open situation, when your firewall just flat out fails, and this is whether it's hardware or software, you need to, in a fail open situation, you're going to allow traffic to flow freely, over the firewall. In a failed closed situation, it's the opposite. So when failed closed, you're going to use this when security is a little bit more important. So if something goes wrong, you're just going to shut the internal system off from the world. That's what's going to end up happening. So you can set it to either fail open or fail closed, depending on what your security concerns are. So also among firewalls, we have two different types in terms of whether it's open source or proprietary. So open source firewalls, there's one where the software, the source code, it's freely available and you can modify it. You can redistribute it if you want to. Example of that is pfSense. So yeah, pfSense is a nice tool that you can use, and you can install this. I've seen Raspberry Pi videos where people have put pfSense on a Raspberry Pi and tried to do a cheap version of a firewall for their home system. I think you can also flash older routers with this. So you can use this open source firewall on your own, or you can go the proprietary route. So proprietary firewall is a firewall that is built by an entity that has exclusive rights to the firewall. There's a lot of them out there. Cisco Adaptive Security Appliance is one of them. You'll see there's other ones out on the market as well from a variety of vendors. But those often come with a pretty big cost, but with that cost comes the security of a brand name behind it, and if something goes wrong, you can get support as well. Furthermore, talking about firewalls, we have firewall types. So there's two main types. One is the stateless firewall, and the other one, of course, is going to be the stateful firewall. So the stateless firewall, that's essentially a packet filter. So what a stateless firewall is doing is it's using a set of rules, or ACLs, access control lists, to decide whether or not it's going to allow traffic to go through it. So it's kind of dumb in that way. So all it's doing is it's looking at the access control list and saying, okay, I'm letting all port 80 traffic come through. I'm letting all HTTP over port 80 come through. I'm letting all, let's say ICMP, messages come through. So it's gonna just go by rules. It's not going to do anything like follow the state of the system. In other words, if you're doing a TCP handshake through the firewall, it's not going to keep track of what stage you're at to make sure that anybody's sending a filter or a packet that's not compliant with what's going on. So the opposite of this is going to be a stateful firewall or a dynamic packet filter. And this is one where the firewall is going to monitor and track the active network connection sessions that you've got going on, and it will block a packet that doesn't belong to an active session. So some people might try taking a packet and sending it through just to see what happens. And if it's not part of a current session, it's going to get rejected because your firewall is going to know what's in play at the time. They're going to know the status of all the connections that are going in and out. So that's really good. It does take a little bit more computation, and it's a little bit more resource heavy to do something like that. So a stateful firewall stores the connection session information in a state table, and it uses the information to make the packet filtering decisions that it makes. So furthermore, we can talk about the network security appliances. So network security appliance is going to combine the functionality of several devices to improve the network security and simplify the management of those devices. So it can have the firewall, included in there, but it's also going to have other things in there like intrusion detection and prevention. It can have malware detection and removal. It can have DDoS protection and all kinds of web content and email filtering. And we call these devices these centralized ones that do many functions like that. We call that a unified threat management system, or a UTM. Um, so the UTM, it simplifies the security management by enabling an administrator to manage a wide range of security functions from a single console. When you think about this, it's nice in that it's simplifying everything, but in the back of your head also, you need to be thinking that, as we talked about in the end of one of our previous sections, we're talking about centralized management versus decentralized management. This goes along the idea of centralized management. So you're also talking about single points of failure here. So you need to keep that in mind as well. Another thing we're going to talk about here is the next generation firewall, and that's a firewall that combines the functionality of the dumb quote unquote packet filtering firewall with other technologies to detect and block a network attack. So these next generation firewalls, often called the NGFW. So the NGFW, they can enforce security policies at the application, the port, or the protocol level. So they have the ability to inspect encrypted traffic, detect and block malware, and perform deep packet inspection, known as DPI, which is another one that's a reused acronym. DPI can also mean dots per inch if you're in the printing realm, but DPI here means deep packet inspection. So DPI enables an NGFW to inspect the data within a packet and identify and block a malicious packet. So they may have the ability also to act on the real-time information that's provided by threat intelligence services to block new threats. So that's known as a next generation firewall. One other thing that we deal with is network access control, or NAC. So we've talked about this a little bit in the past, but a network access control is a security mechanism that manages access to a network by authenticating users and devices, enforcing access policies, and ensuring devices comply with security standards. So the NACs can be implemented as a standalone solution or as a feature or an add-on to a firewall as well. Since we're talking about firewalls, this is something that can be integrated into the firewall. When integrated with firewall, NACs can leverage the firewall's existing infrastructure and policies, making NAC an effective tool for enforcing network security. It's often used in conjunction with 802.1x port security standards that we talked about earlier too. And another thing that is not mentioned in the book here is you'll sometimes see NAC referred to as, sometimes it's a piece of software you install, sometimes it's what they call dissolvable, that you will essentially, when you're connecting, you'll, let's say, download a piece of, software that checks your system, and then afterwards it can be erased. It's just there to, actually look in, make sure that you're okay, and then it will remove itself. So that is something to keep in mind. So that's what we call network access control. And that is it for this section. If you have any questions, feel free to reach out, and I'd be happy to answer any questions you have. Again, a quick recap of this. We're talking about firewalls, whether it's hardware or software based. When things go wrong, uh, what do we do? Do we fail open, meaning we let everything through, or do we fail closed, meaning we shut down our system? We talk about open source firewalls where you've got software source code that's freely available to look and modify and do what you want with, or it could be a proprietary firewall that you buy from a vendor like Cisco. We have firewall types like stateless, where we don't follow the state of the traffic that's going on. We're essentially just a packet filter using access control lists, or we're a stateful firewall that's going through and keeping track of where are we in the communication chain here. We talked about unified threat management where we have several functions in one device. We talked about next generation firewalls where we're doing not just the filtering, the packet filtering, but we're also doing a lot of enforcing security policies at the application port and protocol levels. We're doing deep packet inspection as well. And we also talked about network access control. We're talking about the security mechanism of checking out a system before it's allowed to connect and use resources on our network. So that's it for the chapter. If you have any questions, as always, reach out and I'd be happy to answer. Have a great day.